Hello everyone. Have been looking forward to this section actually. If you're more algebraic minded, you may enjoy it quite a bit because what we're going to be doing in section 5.3 are trig equations. Alright, so for instance, find all the solutions to sine x equals 1 over the square root of 2 exactly. Okay, so think of your unit circle. Where is the sine on a unit circle? 1 over the square root of 2. Well, if you think about it right here, that is at pi over 4. The point is 1 over the square root of 2, 1 over the square root of 2. If you look right here, this still has a sine of 1 over the square root of 2. The cosine is just different. And so that particular point is 3 pi over 4. The way I like to tell people is you could run a line through that and hit those 2 points. That's a way to help you pick them out sometimes. Okay, so now notice it says all solutions exactly. If I were to just write down 3 pi over 4 and 4 pi over 4, 3 pi over 4 and pi over 4, I would just have 2 solutions. What you need to remember with a sine and cosine function is that sine and cosine are infinite in terms of where they go. They go infinitely to positive x, infinitely to negative x. So there are multiple solutions. These are just the 2 solutions from 0 to 2 pi. Okay, these are just the 2 solutions from 0 to 2 pi. And the period of this is 2 pi. So in order to find out the next solution, I would have to start here, and I would have to go all the way around this circle to get to that solution again, and that would be the next solution on my list. Now, how far is it all the way around the circle? Well, it's 2 pi. Same thing here with 3 pi over 4. If I started there and I went all the way around this circle, that's 2 pi. I'm back around to a coterminal angle that has the same sine. So see, this is really about finding coterminal angles that have the same value. So how would I write this? Well, since the period, if I keep going around and around and around the circle, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, I'm still coming up on, so at that point, at this point, and at that point, I'm coming up with more solutions and more solutions and more solutions. So what we say is this: the x equals pi over 4, which we determined, 3 pi over 4, which we determined. But what you have to do is you have to add to that a 2k pi. What this 2k pi does is this takes into account all the integer multiples of 2 pi. All the way around the circle. That takes into account if you're going all the way around. 2 pi, 4 pi, 6 pi, 10 pi, so on. So k will be any integer. Okay? Any integer. So that is how you would find the exact solution. in all the solutions, okay? Now, the thing about sine and cosine, since they have a period of 2 pi, this part right here is not really going to change for sine and cosine. The plus 2k pi, okay? That's really not going to change for them, and I'll show you another example. For instance, let's look at 3 cosine x minus 1 equals 0. Alright, well, we're solving for x, so go ahead and solve. So this is 3 cosine x equals 1. So this is cosine x equals 1/3. So x equals the arc cosine of 1/3. So figure out what that is, punch it out in your calculator. Make sure your calculator's in radian form. And you get 1.23. So if we're looking at a unit circle, $1.23 is somewhere right in here. So that means we have since we're dealing with cosine are the x values. Now, sine were the y values, so that's why we went horizontally on the last problem, because we had the same y values. Now that we have the same x values, we go vertically to find the other value, because these 2 points have the same x, okay? So, and I'm sorry if it sounds like a meeting. I've got a Halls in my mouth, so I won't cough in your ear. Alright, so how do we find this point? Well, the whole circle is 2 pi. And so if we say 2 pi minus 1.23, it will give us this point because it's directly below because this distance and this distance, I know it doesn't look like it, but this distance and this distance should be the same, okay? So if we subtract 1.23 from 2 pi, it will get us this other point, which is 5.05. So when you get ready to write your answer, this is 1.23 is one of the answers. 5.05 is the other answer. And so we have to add our plus 2k pi to both of them, where k is an integer, to cover the infinitely many answers that we have. The infinitely many answers. Now, this right here was 1.23. The whole distance around is 2 pi. So subtract that from 2 pi, and that gives you this, going backwards, it will give you this point right here, for those of you that had a question about that. So, this would be the answer for all the infinite many problems that we have that will give you those 2 particular points. Okay? So, we've looked at sine, we've looked at cosine, they're done much the same way. Sine, to find the other point, we draw the horizontal line because we're dealing with the y coordinates. Now, don't get that confused with axis. The horizontal line, we're looking at distance from the axis, so the horizontal line gives you the same y coordinates. The vertical line, like we drew here, gives you the same x coordinates. So be careful. A lot of people get that confused with the x and y axis. Don't even let that enter your mind, okay? So, let's look at, we've done sine and cosine. They're pretty much done the same way. So, let's look at tangent. Let's look at tangent. So, the square root of 3 tangent x equals 1. So divide both sides by the square root of 3. And that gives us tangent x equals 1 over the square root of 3. So think of your unit circle. Now, where does tangent equal 1 over the square root of 3? Well, that happens to be right here at pi over 6. If you take the sine and cosine of pi over 6, the cosine is square root of 3 over 2. The sine is 1/2. If you divide those, you get 1 over the square root of 3. So, where else on the graph, on our unit circle, does tangent equal 1 over the square root of 3? Well, notice tangent is positive here. So where else is tangent positive? That's what you need to ask yourself. Well, tangent is positive if sine and cosine are both positive, and tangent is positive if sine and cosine are both negative. So what quadrant are sine and cosine both negative? Well, that would be quadrant 3 here. So if we run a line across our circle, that point right there would be the other point where tangent x is 1 over the square root of 3. Now notice this is half a circle away. That's half a circle away. So this particular point is pi over 6 plus pi away, because half a circle is pi, or 7 pi over 6. That would be the other point. Pi over 6 plus pi distance away is 7 pi over 6. Now, but you don't really have to do that. Why is that, Mr. Francis? Because what is the period of tangent? The period of tangent is pi. So if this point here is pi distance away, that means we're going to get to it anyway when we do the period. So you're going to get to another point with that here. If we go pi again, which would be a second period, we're going to come back to this point. Pi again comes back to this point. And that's how we're going to get our infinitely many answers. So when you're doing this when you're solving this problem, there's no need in writing 7 pi over 6 down, because it's going to be included in your period, your plus pi. So we have to do k though, because we have to count 1 pi, that's 1 pi, 2 pi, 3 pi, 4 pi, and so on, going around this circle, okay? So we write this as pi over 6 plus k pi, where k is any integer. So that would be the example, the answer to that. So what you need to get in mind is this. Sine and cosine, to get back to those points, we're going to be adding 2k pi. Tangent, we're going to be adding k pi. It's all because of the period, remember. And getting back around to that exact point, which we learned earlier was a coterminal angle. So getting back around to those coterminal angles. If you go back and look at the coterminal angle section, we actually did this, added these to find coterminal angles. That's what we're doing here. Okay, so now these are a few of the basic equations. The next video for section 5.3 will have some of the more difficult ones.